An important step of any data analysis, especially during the data exploration phase, is to understand the general form of the different variables in your dataset. So for example, for one particular variable, you might want to see if the data points under that variable are close to each other or far away from each other. Also, you want to check if there are any outliers under that variables, so that you might want to exclude them to avoid them affecting your subsequent analysis. Also, you want to see if the data points under a specific variable follow any recognizable pattern, right? All of these things can be studied or investigated by studying the distribution of the different variables. So let's take a look at the major factors or aspects we want to study when it comes to data distribution. Before we get into that, let's take a look at a special graph called the histogram. The histogram is basically a graph for representing the frequency of data points using bars with different heights. Now, think about it. Would it be feasible or efficient to represent the frequency of each data point if we had, for example, 1,000,000 or 2,000,000 data points? It wouldn't be feasible, right? So what we do instead is that we create multiple ranges or bins of the same width and then assign the different data points to each bin. After that, we simply count the frequency of the data points belonging to each bin. So for example, here we have some data points, right? And down here we have created 5 bins to represent the frequency of these data points. This is a bin from 168 inclusive, meaning that 168 is included, all the way to 172 without excluding 172 or exclusive. Another bin from 172 inclusive to 176 exclusive. Another from 176 inclusive to 180 exclusive, and so on and so forth till the end. Now, as you can notice, the width of the bins is the same, right? It's 4. 4 here, 4 here, and 4 here. After we create the bins, we start assigning the different points depending on their values to the different bins. All right. After that, we simply count the frequency or the number of observations belonging to each bin. So in this case, for the bin 168 to 172, we only have one observation. So the count or the frequency is 1. For 172 to 176, clearly we have 4 observations. For 180 to 184, we have 7 observations. So this bin basically has the highest frequency in the data. Right? So make sure to get comfortable with the histogram graph because you are going to use it a lot in order to represent the distribution of the different variables you are dealing with. All right. Now, when it comes to the data pattern or the data distribution, 3 major aspects must be studied. First is the center through the mean or the median, depending on the case. Second, the spread or the variability of the data in the distribution. And third, the shape of the distribution. Now let's take a look at them one after the other. So here we will study the center and spread at the same time because they're kind of closely related, right? So here we have 2 different distributions. Now look at the mean value, assuming that this is the central value we want to consider rather than the median. As you can see, rounding this means the value is 10. The value is 10. For this distribution, rounding to the nearest integer, the mean is also 10. However, look at the standard deviation value for both distributions, which basically represents the spread or the variability in the data. For the first distribution, it's about 14 if we round up to the nearest integer. For the second one, it's about 5, right? So as you can see, although both distributions have the same center, they are completely different when it comes to the variability, right? And this becomes apparent if we look at both graphs here. The values in this distribution range from -20 all the way to 40, which means the values have more variability or more spread out across the range of numbers. On the other hand, here in this distribution, the values range from 0 all the way to 20, right? So the takeaway here is to always judge a distribution by both the center and the spread together, not the center alone. The next aspect of any distribution that we want to study is the shape. All right. Now, there are multiple characteristics for the shape aspect, starting with the symmetry. The symmetry happens basically when half of the distribution is a mirror image of the other half of the distribution. So if we cut off the distribution in half and then we folded this half, then it will be able to completely cover up the second half. The same thing happens in the second distribution here. It's the same. The one half completely mirror image the other is a mirror image of the other half, right? Now, one particularly common and popular symmetrical distribution is called the normal distribution or the bell curve because it takes the shape of a bell, right? In normal distributions, the frequency of the values nearest to the mean is higher than the frequency of the values away from the mean. Of course, in addition to many other characteristics that I encourage you to study on your own, because in the different analyses you will encounter uh, data that is normally distributed a lot. Okay? All right. The next characteristic of the shape aspect is skewness. Skewness basically tells us that fewer observations occur on the right side or as we head towards the right side or the positive side. So as you can see here, the frequency of the values from 1 to 2 is 8, from 2 to 3 is about 7, and so on and so forth. So as we head towards the positive side or larger values, the frequency tends to decrease. And this is called skewed right or right-tailed distribution because we have what resembles the shape of a tail right here. On the other hand, we have skewed left distributions, right? And it occurs when there are fewer observations as we head towards the negative side or as we head towards lesser and lesser values, right? So as we can see here, from 0 to 2, the frequency of the values from 0 to 2 is much less than that of 2 to 3, and 3 to 4, and 4 to 5, and so on and so forth. So definitely pay attention to the skewness characteristic. Okay, the last characteristic is uniformity, and it's usually represented using the uniform distribution. The uniform distribution occurs when all of the data points have the same frequency. right? Or the data points are equally spread across the range of the distribution. One good example is when, for example, we roll a dice 6,000 times. Now, in that case, we are expected to get 1,000 outcomes for each number, right? So we are expected to get 1,000 ones, right? And 1,000 twos, and so on and so forth. This is basically because the probability of getting any number is 1 over 6, right? And if we roll the dice 6,000 times, then we are expected to get 1,000 of each outcome, right? Now, if we represent the frequency of outcomes using a histogram, then we will get the same height for each outcome, right? It would be like this, 1,000 for this one, right? 1,000 for this one, 1,000 for this one. So the data points in this example follow the same distribution, or are said to follow the uniform distribution. Sorry, not the normal, the uniform distribution. Okay. Also, when it comes to understanding the distribution of the different variables, we need to pay attention to some unusual features, mainly represented using or through gaps and outliers. So let's take a look at each. Here in this distribution, we clearly can see that there are certain gaps, right? So we have values from 0 to, for example, 7, right? We have values from 0, sorry, from here to here, right? From 0 to about 2.5, to 5 to 2.5 to 5, and so on and so forth. However, from 10 to 15, there are no values at all. Or more accurately, from about 7.5 all the way to 15. There are no observations at all. So this is called a gap in our distribution. Also, here we can see that there is an outlier. An outlier, as we mentioned before, is an extreme value, right? Or a value that differs greatly from the other observations. Now, there are multiple ways to extract or to spot outliers. One of them is by using the interquartile range that we explained in the previous part. How? By simply getting the first quartile, Q1, and getting the third quartile, right? Now we can form two boundaries. Here, for the one boundary, we would say Q1 minus 1.5 times IQR, or the interquartile range. For the upper boundary, it's Q3 plus 1.5 IQR. Now, any data points less than this value is considered an outlier, and any data points bigger or higher than this value will be an outlier. Because again, this would be evaluated to an actual value, right? It would be, for example, 5, and this would be 15. Anything less than 5 is an outlier. Anything greater than 15 is also considered an outlier.